Okay, so this is kind of the how of how we'll be using these. And all of these examples are already worked out, but I want to kind of show you my thinking and how I get from one thing to the next so you can start to see how this works, okay? So at the very beginning here, we have 1 over sine pi over 2 minus theta. And if you have to, look back at your notes and remember, this comes from that co-function identity, where sine of theta is cosine of 90 minus theta, or the inverse is true, cosine is sine 90 minus theta. So we know that this pi over 2 is the same thing as 90 minus theta. So which function is sine a co-function with? Well, we know cosine. So cosine of theta is equal to sine pi over 2. So what we're doing is replacing all of this stuff with this because we know those two things are equal. So you can just replace them synonymously, right? Is equal to secant of theta. This is the basic reciprocal identity that says that cosine of theta is equal to 1 over secant of theta. So you can do that. Secant of theta is 1 over cosine. So the reason we jump straight to secant here is 1 over cosine of theta is equal to 1 over secant of theta. So I did kind of skip a step there, but you know that this is the same thing as 1 times secant theta over 1, which is equal to secant of theta. So it wasn't perfectly worked out. I didn't show all my work. So you can see that from this crazy trig function, we end up at secant of theta. So before you thought about trig identities, you would have seen that and gone, what in the world is this talking about? But what we're doing is we're trying to rearrange these functions. I want you to think back to when we were doing, way back in algebra, when you were doing solving a system of equations, and you had y equals 2x plus 2 and y equals 3x minus 4. If you wanted to solve that system of equations, what you did, you knew that y is equal to all this stuff, right? So you could take all of this stuff and plug it in for y, right? In order to get that x value first. So you would solve this and say 3x minus 4 is equal to 2x plus 2. 2x plus 2. I said 2 and then wrote 4, don't know why. So you would subtract 2x from both sides, and then you'd have x minus 4 is equal to 2. Add 4, so my x would equal 6, right? Well, now I know x equals 6. So in either of these functions, I could plug in 6 for x and see what my y would be. The reason I'm showing you this is right now you may not see the total purpose of where this is going to come into play, but it does, okay? It does come into play in what we'll be doing later on in calculus and in pre-calculus. So all I'm saying is remember back to this. We knew that y was equal to this, so we could plug that in for any other y. That's essentially what trig identities come down to, is what do you know those functions are equal to, replace those and deal with it from there. Okay, so let's say we start out with cosecant x times secant of x. Okay, well, if you remember, secant of x is one of those reciprocal functions. So secant is 1 over cosine. So anywhere we see secant, we can replace it with 1 over cosine. So here we have cosine of x times secant. We'll just replace the secant with 1 over cosine. So then you know cosine times 1 over cosine is the same thing as cosine divided by cosine, anything divided by itself, 1. So cosecant x times secant x, that whole thing is equal to 1. Okay? Now jumping to this next one. 1 minus cosine squared divided by sine theta. Now remember, I said we would use that Pythagorean identity at a time when we wanted to deal with sine. So I'm thinking, well, what is cosine squared? Well, I remember sine squared plus cosine squared equals 1. So how could I get cosine squared by itself? Subtract that sine squared and know that cosine squared equals 1 minus sine squared theta. So you can replace 1 minus cosine squared with sine squared of theta. Sine squared of theta over sine of theta. So this is the same as saying x squared divided by x. You're just using the power rule, right? So what do you do when you have powers above the same base? What do you do with those powers? That's that invisible 1. If you remember during division, you subtract them. So if you have 2 of something divided by 1, you're left with just sine of theta. So all this crazy stuff ends up as sine of theta. Wild. Okay, down here we get into tangent. So technically it's part of the reciprocal function group. So what is tangent of theta? Well, you remember it's sine over cosine times cosine. So sine over cosine times cosine. Those two cosines reduced to 1, you're left with sine of theta. You starting to follow? You starting to see what is going on here? The only hard thing about videos with me is I don't get to see you guys and see how you're reacting and how you're getting it. So as usual, as you have questions, pause and ask. Okay, so this one you kind of do a bunch of stuff at once. So I want to take it a piece at a time. So secant of theta is the same as 1 over cosine, right? Minus sine times tangent. Well, what is tangent? Remember from that above problem, tangent is sine over cosine. So we're gonna do things piece at a time. So secant is 1 over cosine, we replace that. Sine times sine over cosine. So this reduces to, if you do that multiplication out, sine squared over cosine squared. I mean cosine, not squared, sorry. Sine squared over cosine. Now, if you look at this, this is just a simple subtraction of fractions. So if I had 3/4 minus 1/4, I have a common denominator, what would you do? Well, you'd keep the denominator the same and you'd subtract those numerators. So 3 minus 1 is just 2, right? And you'd be left with 2 over 4 or 1/2. So here, same is true. We have a common denominator already. So all you do, leave your denominator the same, so leave it that cosine, and do 1 minus sine squared. Well, this should start triggering bells for you. Remember, sine squared plus cosine squared is equal to 1. So how could I get this to be 1 minus sine squared? Well, subtract the sine squared to realize cosine squared equals 1 minus sine squared. So now where we see that 1 minus sine squared, replace it with cosine squared. So then we're left with cosine squared over cosine. Again, it's the same as that above, 2 above, where it's power rule. So you have cosine squared divided by cosine. You are left with cosine. Now, can you imagine, from looking at the beginning of this, that all of this would simplify to this? The goal of this is to simplify these, right? So the goal of this is I look at this and I go, shoot, I don't know how to graph that. I don't know how to deal with that. But I do know how to graph the cosine function. This is the same exact thing as this. Crazy. Okay, let's try another one slightly different, okay? So here, we have secant minus cosine of x. So I have 1 over cosine, that's that secant, minus cosine over 1. So now I look at these functions and I go, well, crap, they do not have a common denominator. So if I had 1 over 2 minus 1 over 6, well, what would I do to give these a common denominator? Well, you think, how do I turn 2 into 6? Well, I would multiply both the top and the bottom by 3 over 3, right? Same is true here. So if our denominator here is cosine, I want the common denominator to be cosine. So here, I have to multiply the top and the bottom by cosine, okay? So here, the first part stays the same, 1 over cosine of x. And then cosine times cosine is cosine squared, same as x times x would be x squared. So cosine squared, and then 1 times cosine is just cosine, okay? So now we have that common denominator. Now we can go ahead and simplify this. So remember, common denominator, you can just subtract the numerators and leave the denominator. So you're left with 1 minus cosine squared of x over cosine of x. So as soon as you start seeing these squared and the 1 and all of these pieces together, immediately you should go back to that Pythagorean identity. Oh, you can't see it. So I want to get this to be 1 minus cosine squared. So what I would do is subtract that cosine squared, and I'd be left with sine squared equals, 1 minus cosine squared of theta, right? It's another option for what we could do. Or you could look down here and know, okay, I could just flip these two in their spots. However you need to think about it, just remember, 1 minus cosine squared is sine squared. So this replaces to be sine squared. So this is the same thing as sine over cosine times sine. And why are we doing this sine over cosine piece? We're wanting to simplify this as much as possible. Sine over cosine becomes tangent times sine. And that's the most that you can simplify that one. You could play with it more, you could turn it into different things, but for this one, that is sufficient. Okay, now this one down here. Secant x minus 1 times secant x plus 1. What is this called if you think back to algebra? If it looked like that, what is that called? Okay, hope you're remembering. Remember the difference of squares? And remember that that would be how you would factor that out. So what happens if you wanted to multiply this out and just see what happens? It becomes secant squared of x plus secant of x minus secant of x minus 1, okay? So these two middle terms cancel out and you're left with that difference of squares, because secant squared and 1 squared, right? So this yields this. And if you remember, this is part of our Pythagorean identities that we've not yet proved. Secant is related to tangent. So 1 over tangent squared equals secant squared. 1 plus tangent squared is equal to secant squared. So secant squared x minus 1 is just a rearranging of that. So if 1 plus secant squared, making sure I'm doing that right. Nope, I did it backwards. Ooh, bless. It takes a lot of work at the beginning, and it's been a long time since I've dealt with these, y'all. Hang with me. So secant squared of x equals 1 minus tangent squared. So if I want to simplify this, secant squared of x minus 1 equals tangent squared of x. So this whole thing can be replaced by tangent squared of x. So now it's your turn to try it. Grab that worksheet and see if you can do numbers 1 through 10.